Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and what I have for you today is something a little bit different than usual. Since this week was my birthday, I thought about writing down a wish list for what would be my favorite programming language based on my programming style and on the technology that exists today. So this is what I came up with, and I'm gonna go through this wish list. Before we start, just to make sure we are on the same page, this is just a wish list. These are not features thought up to the end. I'm not a language designer, I'm not a compiler designer. I'm a, let's say, a programming language user who has dabbled with multiple programming languages, and also with I wrote a few small programming languages for fun for myself, but that's all I've done. So with this being said, let's go through this list, and I hope you'll find this interesting. First thing, I split this into three parts: language, delivery, and runtime. On the language part, what I want the language is, first of all, it has to be immutable by default. I think this solves a lot of problems. I love how Rust is doing this. It's really great to have immutability by default. And this means creating the whole structures, whole data, memory management, all that, so that this is possible even for lists. Now, however, what I don't want is to have to use some complex structures to do input-output stuff. And for that, we just mark things as IO or something like that. This is what I like to have. But by default, everything should be immutable unless you specify that it is not immutable and that it needs to mutate. A second thing, which this might sound more complicated and is definitely not something that you find in many programming languages right now, is test first by default. What I mean by that is that every line of code should have a test written, and compilation should fail unless there's a test that checks that line of code. That's how it should be. So you should write the test first and then implement the code to make the test pass, and this is the only way the code compiles. Now, there are exceptions here, and this is why this is by default. Similar with immutability, you should be able to specify some lines of code as exceptions. Exceptionally, these lines of code are not test first, they're not covered by tests, because as we know, if you've done any serious automated testing, there are like 2, 3, 4% of code that it's either too expensive to be tested or it's not that useful to test. So this is something that I would really like. In terms of syntax, I'd like a minimalistic syntax. Think about this as Python on steroids. What I want is very little extra words, extra signs, and so on. So even for Python, I would like to remove def keyword. I would like to remove a few other things. But we should be able to express things in the shortest way possible without a lot of extra. So no semicolons, no special keywords for classes or for, at least not in keywords, we'll see immediately what I'm thinking about, or for functions or things like that. Instead, we have like in a book, right? You already know how to read the book. You have a chapter title followed by empty lines. You then have sections, you have paragraphs. This is how code should look like as well. Another thing is optional types and smart compiler. I did a whole video on why I prefer this. I think optional types are the way to go. So what I want to do personally is to write code that works in a very expressive way, and the compiler should figure out what it's about. I don't want to help the compiler. I don't want to work for the compiler. I want the compiler to figure out what I'm trying to do. Now, occasionally, maybe the compiler can ask me, do you mean this? Then I would say yes, but that is just something that the compiler uses as a hint later on. Maybe. It's an idea. I'm not sure it works. But this is definitely where I would like to see things going. No more writing for the compiler. I want the compiler to do more stuff. Now, this means that most likely this programming language is not for systems programming, and that's okay. If you want to do systems programming, where you need to control a lot of the resources and all that, use Rust, use C++, use, I don't know, Go, whatever is the Zig, whatever is the language that you prefer. And that's fine. It doesn't have to work for everything. It just needs to work for a subset that is useful for multiple programmers, or for most programmers. Another thing that I like to see is that refactoring is a part of the language. What I mean by this is that the compiler understands refactoring. I should be able to tell the compiler, look, I need to extract a function from here. Or maybe, I don't know, the environment. This should be built in the language. So the language should come with support for refactoring. And going from rename, all the extracts, all the inlines, and then a move also, move function to another class, and so on. That's, I think, is the way to go. Refactoring should be part of the language. Tests should be part of a modern programming language. We shouldn't skip on those. Okay. You can also go the other way. You can go with very strong types that have provable behavior. You can go with contracts if you want. That's fine. But my wish list is refactoring, test first, optional types, and smart compiler. Comments. I would like to have no comments in my code, but I'd like to have annotations instead of comments. So imagine when you open the editor, you have two sides for the editor. On the left side, you have the code. On the right side, you have annotations. And you can annotate a line of code, a part of a line of code, maybe a variable. You can annotate anything from the code, and the annotations will be showed in a second column on the right. Of course, this means that you'll need to write more compact code, which is great, right? We want to have more compact code. But annotations, I'm a big believer in documenting the code, but not so much through comments. Comments, I think, are not the greatest thing. But writing things in phrases, in sentences, to explain what is going on in the code, absolutely. I find that very useful. And these annotations should be used for generating documentation, and it should be very easy to include examples from tests, right? So to refer, for example, one of the tests and say, okay, this if statement is used in order to sort out the problem or the case for this specific example from test when I is 0 and you try to divide by 0, whatever. And the next one, which is very in line with minimalistic syntax and with annotation instead of comments, is embrace typography for code. So what I mean by that, imagine that your class name is heading 1 and the members are, I don't know, part of the heading 2, and the functions are also a heading 2, and the code is in paragraphs, and they are actually displayed with different types of fonts, with different spacing, and you can define this like you would have for HTML or something like that. You know, you can define typography for how you can see the code. And this, I think, would make the code much nicer to work with. All right, now let's go to the next section, which is delivery. And in the delivery section, I have 1 point. There are probably more here, but I just thought about one, which is native packaging as Snap and Docker. I think that we need to package natively into formats that are useful. And to me, the most useful ones are snaps. Despite the controversy, one of the great things about snaps is that they update automatically. The user doesn't have to do anything. It's done in the background, and it's great. So it really helps. And Docker, because obviously for servers, for any other types, you need Docker. I also believe that it's very useful to develop in a Docker container, because this gives you information about dependencies that you might not have otherwise. So yeah, you should build your whole development process when you run or debug or run the test. It should happen in a Docker environment. This means that you also need to define your Docker environment for your package, and that's obviously, I think, a good thing. Now, and this will also allow you to deploy easier. Now, the next thing is runtime. For runtime, we should have sandboxing by default. This is something so actually two things, sandboxing and cryptography by default. So sandboxing by default would mean you need to define, so by default you have very little access to resources. You can have access to memory, to CPU, but not to the file system, not to anything else. Everything is sandbox. And you need to define a manifest saying, I only need access to these resources. File names, for example, as regular expressions, let's say. And it can be different sections here. So maybe configure files. It may be storage. It may be files that you need to access as inputs, whatever. I realize this is a pretty complex problem, but I think it would be a good idea to explore. URLs. What URLs am I allowed to call? Not any URL. Network. What am I allowed to call on the network? Am I allowed to go on the local network to call something, or external, and so on? And of course, these are very difficult to define. I know there's a lot of work here, but I think it's a great idea to have the sandboxing by default, because this will remove a host of potential security problems. Like, why, let's say I have a, I don't know, calculator type of program. Does it really need to be able to access URLs or files from my storage, or, you know? And this could be first ask for permissions in the beginning. These are the things that I need and why, much like you do with Android installs. And then the second thing is, some of these would be optional. So maybe you have a calculator and you calculate, but then you need to save at some point, or the user wants to save some more complex computation, and then the program will ask for permission. Okay, do you allow me to save in this location? Or upload, do you allow me to upload here? But one thing I think it's really important is to allow only specific file names, specific paths, and complete paths. Yes, with regular expressions, but limited. So that it's not possible to have, like, I need access to everything. You don't. Most likely you don't. And cryptography by default. Again, this is something that might introduce performance issues, but I think it's important. You should have by default encryption for storing data, for sending over the wire. And maybe you can define the protocols and so on, because the algorithms change. But in general, you know, we'll have a default that we use, which is the last recommended one by NIS, and that's it. You use that, and that's all. So this is my wish list for a programming language, and I'm curious now what you think. Does this sound interesting? Is there any one of these that you are completely disagreeing with? And first of all, as I said, let's acknowledge that this is not for systems programming. This is not meant for low-level programming. This is meant for another type of programs, which is what I guess 80% of developers do. At least that's what I think. And it's a wish list. So is there anything you would add? Is there anything you'd comment? Is there anything you find impossible to do, or difficult, or not very useful? We love comments, so leave us some comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.